This question is asking us to find the specific value for the inverse of a function. It says, if f of x is equal to the square root of 5x plus 1, what is the inverse of 4? So, if we're going to try to evaluate an inverse, we need to find an equation for the inverse of a function. One of the ways that it's often said that you do so is to switch x and y and then solve for y. But in our equation here, we don't have a y, but remember that f of x can be replaced with or substituted with y. So we could write this as y equals the square root of 5x plus 1. And then the strategy is to switch x and y because the domain and the range of a function and its inverse are switched. And then we solve for y. So let's do that. Let's switch x and y. So now this would be x is equal to the square root of 5y plus 1. And now we just undo everything that's being done to y to isolate y. So the first thing we want to do is get rid of the radicals. So let's square both sides. That leaves us with x squared is equal to the square root of 5y plus 1 squared is just 5y plus 1. And now let's subtract 1 from both sides. That gives us x squared minus 1 is equal to 5y. Y is almost by itself, but we need to divide both sides by 5. And that leaves us with x squared minus 1 divided by 5 is equal to y. And once you've switched x and y and then solved for y, you can replace that y with the inverse. You have now solved for the inverse. So once you have it equal to y, you can say that this is the inverse function of x. Okay, so now we're asked to evaluate the inverse at 4. So let's just show that here. The inverse of 4, everywhere in the inverse that we have at x, we're going to plug in 4. So that looks like this. 4 squared minus 1 divided by 5. Well, 4 squared is 16. So this is 16 minus 1 divided by 5. 16 minus 1 is 15. So this is just 15 divided by 5. And we know that 15 divided by 5 is 3. So the value of the inverse at 4 is equal to 3. And we can find that in selection B.